Close your eyes for 1 second and picture a tiny, round sensor at the center of the human chest, delicate, public, and private at once. Now imagine that sensor has a password, a firewall, and a network address. Welcome to a story where Nipples meet cybersecurity, and where biology and bytes collide in deliciously practical ways. I walk into a lab. Whiteboard on the wall reads, sensitivity equals signal plus context consent. On the bench there are two items, a traditional tactile stimulator and a internet-connected wearable. A graduate student taps a touch screen and the device pulses. The subject smiles, frowns, or asks for the session to stop. That simple moment contains layers. Nerve endings, cortical maps, privacy expectations, and a host of potential security flaws. What data is collected? Who can access it? How do we authenticate desire? And how do we prevent a breach of intimacy? Think of the nipple as a node in a human network. Its afferent pathways are like cables carrying touch to the brain. Those cables can be measured with microneurography and fMRI. They can be modulated by hormone, context, and learning. They are also contextual. The same touch in a medical exam feels different from the same touch in a bed. Context is the metadata. Consent is the authentication protocol. Privacy is the encryption layer. Now add the Internet of Play, sex tech devices that stimulate, monitor, and sometimes record. They offer opportunities and risks. A misconfigured API can leak data about a user's body, habits, and internet preferences. A weak password on an app can become a breach of trust. As researchers, we can map the attack surface. What sensors do devices expose? What metadata do they generate? We can design studies to quantify user perceptions of risk, to test disclosure thresholds, and to prototype consent flows that are usable and respectful in heated moments. Picture an experiment. Half the participants interact with a classic device. The other half use a device with a layered consent protocol, verbal consent, digital confirmation, and a short cooling off period. We measure skin conductance, heart rate variability, subjective comfort, and willingness to share data. We log any discrepancies between expressed consent and inferred arousal. We analyze the neural signatures with portable EEG to see if consent status changes cortical processing of touch. We interview participants about privacy norms. The results could inform both clinical guidance and device design. We can borrow tools from security, threat modeling, red team testing, encryption standards. We can also borrow from sexology, contextualized consent, erotic script, cultural norms, combine them, create a consent by design framework for effective wearables, build a taxonomy of nipple-related data, raw sensor streams, derived features, inferred states like arousal and behavioral metadata, classify risk and propose mitigation, local processing instead of cloud, strong default privacy, transparent data deletion, and easy revocation of consent. There are ethical crossroads. How do we protect vulnerable populations? How do we avoid pathologizing normal variation and sensitivity? How do we design for accessibility and pleasure without commodifying body? These are not abstract questions. They are urgent, practical, and fast. So, are you curious? Imagine writing the protocol, running the pilot, and publishing the first interdisciplinary paper that maps sensory biology to privacy architecture. Imagine securing the next generation of intimate devices so people can explore their bodies without worrying about being hacked. Come join the experiment. Let's encrypt desire, authenticate consent, and build a future where pleasure and privacy travel together, safely and boldly.